So we can now apply the formula as integral ax plus b power n dx. That's the same like as integral 0 to 2 pi pi minus x whole square dx. So equal to constant 1 by 4 pi. We can now integrate value is pi minus x whole cube by minus 3. So we can apply the lower limit 0 and the upper limit 2 pi. So equal to 1 by 4 pi. We can now using the upper limit as 2 pi. So replacing x by 2 pi, pi minus 2 pi whole cube by minus 3. Therefore pi minus 2 pi is minus pi. So minus pi whole cube, that is minus pi cube by minus 3. Minus minus cancel. So finally pi cube by 3. And then we can apply the lower limit. So formula is minus. We can using replacing x to 0. Pi minus 0 whole cube by minus 3. That is pi cube by minus 3. Already minus is starting. Therefore minus 1 square plus. Therefore pi cube by 3. The final answer is equal to 1 by 4 pi. Pi cube by 3 plus pi cube by 3. Pi cube by 3 plus pi cube by 3 is a simplification. 2 pi cube by 3. Therefore we can cancel in the calculated value. So finally we get a naught equal to pi square by 6. A naught is pi square by 6. We can store now a naught by 2. That means pi square by 12. We can now find out the Fourier coefficient in n equal to the formula is 1 by pi integral 0 to 2 pi f of x cos nx dx. Therefore equal to 1 by pi integral 0 to 2 pi. We can using the value of f of x is pi minus x whole square by 4 cos nx dx. Okay, next. The 4 equal to 1 by 4 pi. 4 is constant, so taken outside. So equal to 1 by 4 pi integral 0 to 2 pi pi minus x whole square cos nx dx. So here the integral 0 to 2 pi pi minus x whole square cos nx dx. So we can apply the Bernoulli's formula. What is the Bernoulli's formula? Integral u dv equal to uv minus u dash v1 plus u double dash v2 minus u triple dash v3 plus etc. Here u dash, u double dash, u triple dash. What are the notations? That is the successive differentiations of u with respect to x. And then v1, v2, v3 etc. What do you mean by the notations? These are the successive integrations with respect to x. So integral of u dv equal to uv minus u dash v1 plus u double dash v2 minus u triple dash v3 plus etc. So we can using this Bernoulli's formula here. So 1 by 4 pi integral 0 to 2 pi pi minus x whole square cos nx dx. By Bernoulli's formula is integral of u dv. So I will take as u as pi minus x whole square, dv as cos nx dx. dv as cos nx dx. That means how do we find out v? dv equal to cos nx dx. We can integrate cos nx into d of v. Therefore v is sin nx by n. Therefore the u dv format is u is pi minus x whole square, d v is sin nx by n. So we can using the formula 1 by 4 pi pi minus x whole square u b sin nx by n minus u dash. U dash means you can differentiate u. That means here what about the value of u here? Pi minus x whole square. So you can differentiate pi minus x whole square. That is 2 pi minus x. Pi minus x differentiate. Pi differentiation of constant pi is 0. Differentiation of minus x is minus 1. Therefore 0 minus 1 is minus 1. Already 2 pi minus x minus 1 is minus 2 pi minus x. That is u dash. You can now integrate sin nx by n. What about sin nx by n? So how do you integrate sin nx? Sin nx is minus cos nx by n. Already here 1 by n. So minus cos nx by n square. That is v1 value is minus cos nx by n square plus uv minus u dash v1. Next u double dash v2. What about u double dash? you can differentiate u dash, that is minus 2 pi minus x. So minus 2 is constant, pi minus x can differentiate, pi differentiation of pi is 0, minus x differentiation 1. Therefore minus 2 into minus 1, we get finally 2. And then v2 you can find out. What about v2? Integration of v1. What about integration of v1? Integration of minus cos nx by n square. Here constant is minus 1 by n square. You can now integrate cos nx, that is sin nx by n. So finally minus sin nx by n cube. Okay. So here 1 by 4 pi value uv minus u dash v1 plus u double dash v2 minus u triple dash. But u triple dash means differentiation of u double dash. What is the value of differentiation of u double dash here? That is 2. So differentiation of 2 is 0. So we can stop here the Bernoulli's formula here. So and then we can apply the value 0, 2 pi. That is lower limit is 0 and upper limit 2 pi in x. So generally we know that cos 0 is 1. Sin 0, 0. Cos n pi, what is the formula of cos n pi is minus 1 power n. Sin n pi is always 0. Cos 2n pi is 1. Sin 2n pi is 0. So these are the basic facts of the to compute this integration. So we can now integrate 2 pi and 0. So we can apply the sin nx by n. So upper limit sin 2n pi is 0 and then always lower limit we can apply sin 0 is 0. So in both upper limit and lower limit the value of sin will become 0. So we now cancel here. The same procedure we can using the last step 2 into minus sin nx by n cube. So sin 2n pi is 0 upper limit and then sin 0 is 0. So in upper limit and lower limit values of both value will become 0. So we can also here also cancel these terms. So the two terms are cancelled, the remaining only one term. Because of that the value is persisting here. Because of the upper value of cos 2n pi is 1, cos 0 is 1. So the value is remaining here. So I can go to next step. So equal to 1 by 4 pi. So we can apply the upper limit 2 pi. So cos 2n pi by, that is 2 pi by n square. We can using the lower limit 0, we get 2 pi by n square. So 2 pi by n square here is 2 terms. Therefore 4 pi by n square. So after cancellation of 4 pi, we get finally an is 1 by n square. Now we can find out bn. So bn equal to, that is the Fourier coefficient, 1 by pi integral 0 to 2 pi f of x sin nx dx. So the same procedure for an. So I will now substituting the value of x here. F of x is pi minus x whole square by 4. Therefore equal to 1 by pi integral 0 to 2 pi pi minus x whole square by 4 sin nx dx. So the constant is 1 by pi and 1 by 4. I will take an outside in the next step. Therefore equal to 1 by 4 pi integral 0 to 2 pi pi minus x whole square sin nx dx. This format is in the Bernoulli's formula. That is Bernoulli's formula is already said. That is integral of u dv equal to uv minus u dash v1 plus u double dash v2 minus u triple dash v3 plus etc. So we can clearly u is pi minus x whole square. I will take as dv is sin nx dx. How do you find out v? You can integrate sin nx dx, we get to find v. So that is integration of sin nx. What about integration of sin nx? Minus cos nx by n. So in the next step we can write it as equal to 1 by 4 pi integral 0 to 2 pi pi minus x whole square d of minus cos nx by n. So clearly here is u is pi minus x whole square, b is minus cos nx by n. So applying Bernoulli's formula, u is pi minus x square, b is minus cos nx by n minus u dash, that means differentiation of u, that means differentiation of pi minus x whole square. So we can get u dash is minus 2 pi minus x. And then v1, what is the v1? Integration of b. What about integration of b here? minus cos nx by n. So integral minus cos nx by n dx is minus sin nx by n square plus u double dash. U double dash is differentiation of u dash. What is the differentiation of u dash? So minus 2 pi minus x, you can differentiate, finally 2. So u double dash is 2, and then v2. What is the v2? Integration of v1 or dx. What is the integration of v1? Integration of minus sin nx by n square. So minus sin nx by n square. Sin nx means minus cos nx by n. So minus minus will be plus. So already given n square in denominator. So we can in the formula by n x square into n cube, that is cos nx by n cube. So we can now the limits 0 and 2 pi. So 0 and 2 pi upper limit, the same procedure following as an. So sin nx will be cancelled because of upper limit using 2 pi, sin 2n pi is 0, and the lower limit we can apply the x as 0, sin 0 is 0. So that I will cancel this term. So remaining only 2 terms are there. We can apply the value of upper limit, that is upper limit x is replacing x 2 pi. So pi minus 2 pi is minus pi whole square is pi square. Here is minus cos nx by n. Cos 2n pi is 1. So minus 1 by n. So already, so we can finally computing this value minus 1 by n pi square. Minus 1 by n pi square. In final last stage, so we can apply 2 cos 2n pi 1 by n cube. So 2 into 1 n cube is 2 by n cube. And then we can using upper lower limit 0. So our lower limit means we can using the formula extra minus 1. So pi minus 0 square equal to pi square, minus cos 0 by n is minus 1 by n. Therefore we can computing these two values 1 by n pi square, and then we are applying the lower limit for last. Also minus, so 2 cos 0 by n cube is 2 by n cube. So here or minus 1 by n pi square plus 1 by n pi square will be cancelled. 2 by n cube minus 2 by n cube is also cancelled. Therefore the value will become 0 into anything. Therefore 0. Therefore Bn equal to 0. So we can find out. So A0, An and Bn. We can apply the Fourier series formula. F of x equal to A0 by 2 plus sigma n equal to 1 to infinity an cos nx plus sigma n equal to 1 to infinity bn sin nx. Therefore bn is 0. So cancel. An is 1 by n square, and then a0 is pi square by 6, but a0 by 2 is pi square by 12. So we can using the limit f of x equal to pi square by 12 plus sigma n equal to 1 to infinity 1 by n square cos nx. So we can expand in this series. Therefore bn is 0, the last term is 0. We can using the expansion of the series. So f of x equal to pi square by 12. We can apply the value of n equal to 1 in first. Therefore cos 1x by 1 square. So sigma means plus summation plus. We can using the applying n equal to 2 cos nx by n square. So cos 2x by 2 square plus next n equal to 3 cos 3x by 3 square plus etc. This is the Fourier series for f of x in the interval 0, 2 pi for f of x equal to pi minus x square by 4. So we can now find out the values. So here is also to prove that 1 by 2 square minus 1 by 2 square plus 1 by 3 square minus etc. is equal to pi square by 12. Pi square by 12. Pi square by 12. So here we can apply the value x. So x is 0, pi, 2 pi. The three values we can be applying here. How do you get the next to prove that? Okay. So we can now, so in three values here the suitable value is x equal to pi. So we can using the x equal to pi. So f of x, that is f of pi equal to pi square by 12 plus minus 1 by 1 square plus 1 by 2 square minus 1 by 3 square plus etc. So here minus is common. So I taken outside minus here. Therefore minus of 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus etc. So f of pi we can using the value pi minus x whole square by 4. X is pi, therefore pi minus pi whole square by 4. Pi minus pi is 0, so 0 square by 4 will be 0. So 0 equal to pi square by 12 minus of 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus etc. So it's 0 here. So minus of this value coming this side plus. Therefore the final answer is 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus etc. equal to pi square by 12. We will now see that the Fourier series, the same period 2 pi, but the interval is minus pi to pi. Before we can see that the interval is 0 to 2 pi. Now we see that interval minus pi to pi. Okay. So the formula for minus pi comma pi. If f of x is defined in the interval minus pi comma pi, then f of x equal to a0 by 2 plus sigma n equal to 1 to infinity an cos nx plus sigma n equal to 1 to infinity bn sin nx, where the Fourier coefficients a0, an and bn. What is the value of a0? Equal to 1 by pi integral minus pi to pi f of x dx. An is 1 by pi integral minus pi to pi f of x cos nx dx, and then bn equal to 1 by pi integral 0 minus pi to pi f of x sin nx dx. In the before we can see the interval 0 comma 2 pi, the integral limit is lower limit is 0 and then 2 pi. But here the interval is minus pi comma pi. So I will take as integral limits, lower limit is minus pi and then plus pi. Only these two difference in 0 comma 2 pi minus pi comma pi. So here also we can write it as a Fourier series for that interval minus pi comma pi for the function f of x. Okay. So you see the one example. If f of x is defined in the interval minus pi comma pi means we can choosing this minus pi comma pi. So the f of x is even. Suppose the formula becomes f of x equal to a0 by 2 plus sigma n equal to 1 to infinity an cos nx. Okay. Here bn is 0. That means function is even. In the interval minus pi comma pi, the bm terms will become 0, where here a0 equal to 2 by pi integral 0 to pi f of x dx, and in an equal to 2 by pi integral 0 to pi f of x cos nx dx. But by previous formula, it is the function is even or odd or neither even nor odd. That is a general formula. But here in the interval minus pi comma pi, function is even. The special formula is this. That is the value of bn is 0. The function, the Fourier series only f of x equal to a0 by 2 plus sigma n equal to 1 to infinity an cos nx, where a0 this and an this. What do you mean by even function? First you know that even function. If some function is even, that is f for definition means a function f of x is said to be even if f of minus x equal to f of x. A function f of x is said to be even if f of minus x equal to f of x. Here one thing I will give that here note the example is f of x equal to x square. We can find out f of minus x. What is f of minus x? You can replacing x by minus x. Therefore, f of minus x equal to minus x whole square. So, minus square means plus x square. So, for x square, what is the x square here? F of x. Therefore, f of minus x equal to f of x. Therefore, f of x is even. Okay. So, this is the example for function is even. So, this is a special case for the interval minus pi comma pi. The function is even, the formula is given here, and then the same procedure as an odd function. That was in the interval minus pi comma pi. So what is the first to define the odd function? Odd function means f of x is said to be odd if f of minus x equal to minus f of x. So f of minus x equal to minus f of x. Here given as the example, f of x equal to sin x. What is f of x? So f of minus x, you can replacing x by minus x in f of x equal to sin x. Therefore, f of minus x equal to sin of minus x. That is minus sin x. So this clearly minus f of x. So f of minus x equal to minus f of x. Therefore, f of x is odd function. So we can derive the formula for Fourier series in the interval minus pi comma pi. If suppose the function is odd function, then what is the Fourier series formula? If f of x is defined in the interval minus pi comma pi and f of x is odd, then f of x is equal to sigma n equal to 1 to infinity bn sin nx. Here a0 and an, the Fourier coefficients are 0 because the function is odd. So we can only concentrate the value of bn, Fourier coefficients. So what is bn? Equal to 2 by pi interval 0 to pi f of x sin nx dx. bn equal to 2 by pi integral 0 to pi f of x sin nx dx. So Fourier series period 2 pi interval minus pi comma pi. We can see now here. Okay. So just we will give the one formula. Obtain the Fourier series for the function e power ax in minus pi comma pi. Clearly here e power ax, that is the function f of x, it is neither even nor odd. This is neither even nor odd. So we can use only general formula. So it does not satisfy f of minus x equal to f of x, that is function is even, and then does not satisfy the relation f of minus x equal to minus f of x. So it is neither even nor odd. So we can using the general formula. So given f of x equal to e power x, interval is minus pi comma pi. If f of x is defined in the interval minus pi comma pi, then the formula is, so we can using the general formula. So all coefficients a0, an and bn are here. So f of x equal to a0 by 2 plus summation n equal to 1 to infinity an cos nx plus summation n equal to 1 to infinity bn sin nx, where a0 equal to 1 by pi integral 0 to minus pi to pi f of x dx, an is 1 by pi integral minus pi to pi f of x cos nx dx, bn equal to 1 by pi integral minus pi to pi f of x sin nx dx. So we can now find out the value of a0, that is Fourier coefficient a0. What formula? 1 by pi integral minus pi to pi f of x dx. What is here f of x? E power ax. So equal to 1 by pi integral minus pi to pi e power x dx. So integration of e power ax, that is e power ax by a. Okay. So limit is minus pi to pi. Using here the upper limit pi and replacing x, that is e power a pi by a. Formula is minus. We can using the lower limit minus pi, that means e power minus a pi by a. So a is common in denominator. So we can using the simplification, approximation a0 equal to 1 by pi e power a pi minus e power minus a pi by a. So a0 by 2 means we can using 2 a taken outside. Therefore a0 by 2 equal to 1 by a pi e power a pi minus e power minus a pi by 2. So generally this is the formula for sin hyperbolic x. What is sin hyperbolic x? E power x minus e power minus x by 2. E power x minus e power minus x by 2 is sin hyperbolic x. But here is e power a pi minus e power minus a pi by 2. Therefore sin hyperbolic a pi. So clearly here a0 by 2 equal to 1 by a pi sin hyperbolic a pi. Therefore a0 by 2 is 1 by a pi sin hyperbolic a pi. We can now find out the Fourier coefficient an. An is 1 by pi integral minus pi to pi f of x cos nx dx. So what is the value of f of x? E power x. So e power x cos nx dx. We know already the general formula for integration. Integral e power ax cos bx dx equal to e power x by a square plus b square a cos bx plus b sin bx. So we can using the integral formula here. So 1 by pi integral minus pi to pi e power x cos nx dx. So e power 1 by pi e power x by a square plus n square a cos nx plus n sin x. So it is minus pi to pi. The same idea from the before problem. So we can using the upper limit sin n pi is 0, Sine of n of minus pi is always 0. So we can cancel here this term n sin nx. So single term is, the remaining term is 1 by pi e power x by a square plus n square a cos nx. So we can apply the upper limit pi, therefore 1 by pi e power x pi by a square plus n square a cos n pi is minus 1 power n. So cos n pi is minus 1 power n. We can apply the lower limit minus pi, therefore e power minus a pi by a square plus n square a cos n minus pi. We know already that cos of minus theta is cos theta, therefore cos of n minus pi is cos n pi here remaining. So what is cos n pi is minus 1 power n. So in these two terms, the common term is a minus 1 power n by a square plus n square. So we will take an outside the common term, therefore a minus 1 power n by a square plus n square. The remaining term is this grouped here, e power a pi minus e power minus a pi. So e power a pi minus e power a pi by 2, adjustment is 2. Therefore e power a pi minus e power minus a pi by 2 is sin hyperbolic a pi. Therefore finally we get a is 2a sin hyperbolic a pi by pi minus 1 power n by a square plus n square. So clearly here a n we can found out. Now next we can find out bn. The formula bn is 1 by pi integral minus pi to pi f of x sin nx dx. Therefore formula integral e power x sin nx dx is e power x by a square plus b square a cos n a sin bx minus b cos bx. We can using the integral formula here. So 1 by pi integral minus pi to pi e power x sin nx dx. So we can use the formula here equal to 1 by pi e power x by a square plus n square a sin nx minus n cos nx. So here clearly sin nx, using the upper limit sin n by 0. You can apply the lower limit minus pi, that is sin n of minus pi is always 0. So the two upper limit and lower limit, the value will become 0. I will cancel here. So we remaining the term is 1 by pi e power x by a square plus n square minus n cos nx. So we can now here apply the upper limit pi. Therefore e power x by a square plus n square minus n cos n pi. Cos n pi is minus 1 power n. And then we can use in the lower limit. So formula is minus. We can use in the lower limit minus pi. That is e power minus a pi by a square plus n square minus n. Cos n of minus pi is cos n pi. Cos n pi is minus 1 power n. So we can substitute here. Therefore minus n minus 1 power n. Clearly the common term is minus n minus 1 power n by a square plus n square. We can take an outside from here. Therefore 1 by pi minus n minus 1 power n by a square plus n square bracket e power a pi minus e power minus a pi. We can small adjustment by 2 into 2. Okay. So the 2 is 2 sin hyperbolic a pi. So bn value is 2 by pi sin hyperbolic a pi minus 1 power n plus 1 by n. So minus 1 power n plus 1 into n by a square plus n square. So we now find out a naught, an and bn. We can substituting in the Fourier series formula. F of x equal to a naught by 2 plus sigma n equal to 1 to infinity an cos nx plus sigma n equal to 1 to infinity bn sin nx. Okay. So we can apply the values a naught by 2 and then a2 and then bn. So finally f of x equal to 2 by 2a pi sin hyperbolic a pi plus 2a sin hyperbolic a pi by sigma n equal to 1 minus 1 power n by a square plus n square cos nx plus 2 sin hyperbolic a pi by pi sigma n equal to 1 to infinity minus 1 power n by a square plus n square sin nx. So this is the common term is 2 sin hyperbolic a pi by pi. So you will take an outside from here. So 2 sin hyperbolic a pi by pi bracket 1 by 2a plus a is constant outside, a sigma n equal to 1 to infinity minus 1 power n by a square plus n square cos nx plus sigma n equal to 1 to infinity n minus 1 power n plus 1 by a square plus n square sin nx. So summation means here you will imagine as variable is n. So I will take an outside common a, but you don't take the n outside because summation is starts from n equal to 1 to infinity. So a is taken outside, but here n is not taken outside. So this is the Fourier series formula for this problem. Next, so we using the idea is neither even nor odd. We will now discuss about odd function. How do you find out the function is odd function in the interval minus pi comma 2 pi? That is the period is 2 pi. So we will now discuss about the interval odd function. Okay. So find the Fourier series of f of x equal to x in minus pi less than x less than pi, and hence reduce that. Here also deduce, that is pi by 4 equal to 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus etc. So in the interval minus pi comma pi, in before some f of x equal to e power ax, which is neither even nor odd, but here f of x equal to x, we will check out the first which is even or odd, because the interval is minus pi to pi. So I will check here f of x equal to x. So f of minus x, so replacing x by minus x in f of x equal to x, f of minus x equal to minus x, that is equal to minus f of x. So clearly f of x is odd function. So we can using the formula for odd function in the interval minus pi comma pi. What is the formula for? Already we know that the formula, study about the formula, but here also. So f of x is odd function and f of x is the divided in the interval minus pi comma pi. Then f of x equal to sigma n equal to 1 to infinity bn sin nx, where bn equal to 2 by pi interval 0 to pi f of x sin nx dx. This function is odd function, so a0 and an values are 0. So we can only find out the value of bn and applying the formula, and finally we get the Fourier series for the sum. So okay, now we can find out work out the value of bn. Okay, work out the value of bn. So bn equal to 2 by pi integral 0 to pi x sin nx dx, because x is f of x, x sin nx dx. Again, this is like as the Bernoulli's formula, integral of u dv. So here is u. What about dv? dv is sin nx dx. What is the integration of sin nx dx? What is the sin nx dx integration? Minus cos nx by n. Therefore 2 by pi integral 0 to pi x d of minus cos nx by n. So using Bernoulli's formula, 2 by pi, the first term x, second term minus cos nx by n, that is uv, minus u dash v1. What is u dash? Differentiation of x, that is 1. What is v1? Different integration of minus cos nx by n. Therefore minus sin nx by n square. Generally we can using the lower limit and upper limit, pi n to 0. So we get the value, it become in upper limit sin n pi is 0, sin 0 is 0. So I will totally cancel that term. So remaining only one term, that is 2 by pi x minus cos nx by n. So limit is 0 to pi. We can apply the limit x upper limit pi. So about 2 by pi minus cos n pi by n. Cos n pi is minus 1 power n. Therefore pi minus 1 minus of minus 1 power n by n. The lower limit x will be 0. The lower limit will be 0. Therefore 2 by pi minus of minus 1 power n. Therefore minus is minus 1 power 1 minus 1 power n. So minus 1 power 1 into minus 1 power n, we can calculating the value minus 1 power n plus 1 by n. Therefore bn is 2 times of minus 1 power n plus 1 by n. Okay, so we can find out, we can apply the Fourier series. F of x equal to 2 times of sigma n equal to 1 to infinity minus 1 power n plus 1 by n sin nx. We can apply the values n equal to 1. Therefore equal to 2 sin x by 1 minus sin 2x by 2 plus sin 3x by 3 minus etc. That means we can apply the value 1, n equal to 1, that is minus 1 power 1 plus 1 by 1 sin 1x, minus 1 power 1 plus 1, 1 plus 1 is 2, minus 1 power even power is 1, so minus 1 power 2 is 1, sin n is 1, sin x by 1, and then summation, so plus, we can apply the n in 2, therefore minus 1 power 2 plus 1 by 2 sin 2x, 2 plus 1 is 3, So minus 1 power 3 is minus 1. Therefore minus sin 2x by 2. And then we can plus summation plus we can apply n equal to 3 minus 1 power 3 plus 1 by 3 sin 3x. So for 3 plus 1 is 4 minus 1 power 4 is 1. So minus 1 power 4 is 1 sin 4x by 4, that is sin 3x by 3. So minus etc. So from this series we can deduce the pi by 4 equal to 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus etc. Here we can apply the values 0, pi by 2, pi, 2 pi. Here clearly suitable the value is x equal to pi by 2. Because of that we can substituting replacing x by pi by 2, we can get clearly 1 minus 1 by 3 plus 1 by 5 minus 1 by 7. So replacing x by pi by 2, that is f of pi by 2. F of x equal to x, therefore f of pi by 2 equal to pi by 2 equal to 2 sin, we can apply x is also pi by 2, sin pi by 2 is 1 by 1, sin 2 pi by 2, 2 is cancelled, sin pi is minus 1, minus therefore minus 1 by 3, and then sin 3 pi by 2 plus 1 by 5 minus 1 by 7 etc. So this 2 comes here, therefore pi by 4 equal to 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus etc. Okay. So this terms are sin pi by 2 is 1, sin 2 pi by 2, 2 will be cancelled, sin pi is 0, 0 by 2 0, so no term in here, and sin 3 pi by 2, sin 3 pi by 2 is minus 1, therefore minus 1 by 3, so this value will be 1 by 1, put on x equal to pi by 2, this value becomes 0, put on x equal to pi by 2 here, minus 1 by 3, put on x equal to pi by 2, sin 2 pi will become 0, so no term here, and then plus 1 by 5 minus 1 by 7 plus etc. So after simplification we get pi by 4 equal to 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus etc. This is the odd case. Okay. So we will now find out the even case. This the Fourier series period 2 pi interval minus pi 2 pi function is even function. So generally, so this I will take one example. Expand the function f of x equal to x square by 2 minus x square by 4 in Fourier series in the interval minus pi comma pi. Here the question is f of x equal to x square by 2 minus x square by 4. Okay, wow. Okay, so you can so after simplification given f of x equal to x square by 2 minus x square by 4, so taking an LCM, okay, so multiplication 2x square minus x square by 4 equal to x square by 4. Therefore f of x equal to x square by 4 in the interval minus pi comma pi. Now f of minus x, because the interval minus pi comma pi we can check out which is either even nor odd. Sorry, it is either even or odd or neither even nor odd. So I will check the answer. F of minus x equal to, that means replacing x by minus x in f of x equal to x square by 4. Therefore f of minus x equal to minus x whole square by 4 equal to x square by 4. That is f of x. So f of minus x equal to f of x. So the function f of x is an even function. Okay. So for that interval minus pi comma pi, period is 2 pi minus pi comma pi, the function is an even function. We can using the formula, you already know that, but I will repeat it here. So if f of x is an even function and if function is defined in the interval minus pi comma pi, then f of x equal to a naught by 2 plus summation n equal to 1 to infinity a n cos nx. Okay. So we can here bn is 0 because even function. So the value coefficient bn is 0. We can find out a naught and a n. Okay. So what is the a naught and a n? We can now to find out calculating this value. A naught equal to, so a naught equal to 2 by pi interval 0 to pi f of x dx. So we can, and then a n is 2 by pi interval 0 to pi f of x cos nx dx. So a naught equal to 2 by pi interval 0 to pi f of x is, what is f of x? X square by 4. So the constant is 2 by 4 pi. I will take outside and the only integral for variable is x. So interval 0 to pi x square dx. So interval 0 to pi x square dx integration will be x cube by 3. So 1 by 2 pi x cube by 3 interval with 0 to pi. Therefore 1 by 2 pi upper limit is pi cube by 3 minus lower limit is 0 cube by 3. So no term is here. Therefore 1 by 2 pi cube by 3. That is after simplification we get pi square by 6. But the value of a naught is here pi square by 6. A naught by 2 means pi square by 12. Pi square by 12. Next. So an. So what is an? 2 by pi integral 0 to pi f of x cos nx dx. What is here f of x? X square by 4. So I will take outside the constant 4. Therefore 2 by 4 pi. So cancellation 1 by 2 pi. So remaining is integral 0 to pi x square cos nx dx. The same using the Bernoulli's formula. X square is u, cos nx dx equal to dv. We can integrate, we will find out v by integration of cos nx dx. So that means integration of cos nx dx means sin nx by n. Therefore equal to 1 by 2 pi integral 0 to pi x square d of sin nx d by n. This is the Bernoulli's formula. Therefore we can using the same format equal to 1 by 2 pi uv. What is u? X square. What is v? Sin nx by n minus u dash v1. What is u dash? That is differentiation of x square. Differentiation of x square is 2x. Differentiation integration of sin x by n is minus cos nx by n square. That is v1 plus u double dash v2. What is u double dash? Differentiation of u dash. That is differentiation of 2x. So that is 2. v2. What is the v2? The integration of v1. Therefore integration of minus cos nx by n square. So you can integrate this value minus sin nx by n cube. And the next term is u triple dash. U triple dash means differentiation of u double dash. Differentiation of 2 is 0. So I will stop the value. And then applying the limit 0 comma 2 pi. So sin nx here 2 terms. So I am applying the upper limit sin n pi 0, sin 0 0. So the 2 terms will be cancelled. The remaining only one term is 1 by 2 pi minus 2x minus cos nx by n square. Therefore 1 by 2 pi we can apply the limit of x equal to pi. 2 pi cos n pi is minus 1 power n by n square. Here also minus, here also minus. I will take as minus into minus plus. 2 pi will be cancelled. The remaining is minus 1 power n by n square. Minus 1 power n by n square. Next. So we can apply the values of a0 and an in the Fourier series. F of x equal to pi square by 12 plus summation n equal to 1 to infinity minus 1 power n by n square cos nx minus 1 power n by n square cos nx. Therefore equal to pi square by 12 plus we can apply the summation value n equal to 1. Therefore minus 1 power n is minus cos 1x is cos x by 1 square plus we can using the plus summation plus n equal to 2, that is minus 1 power 2 is plus 1. Okay, so cos 2x by 2 square summation minus 1 power 3 is minus cos 3x by 3 square plus etc. I will take a minus from outside from this box. Therefore minus taken outside. So f of x equal to pi square by 12 minus cos x by 1 square minus cos 2x by 2 square plus cos 3x by 3 square minus etc. So we can discuss about the Fourier series in period 2 pi. So the two cases we can see. First case is 0 comma 2 pi and another case is minus pi comma pi. So in another case minus pi comma pi you can subdivisions are there. What are the subdivisions? 3 subdivisions. So I will speak here. The one is neither even nor odd, and another is function is even, and another is function is odd. So in the 3 cases we can use the general formula f of x equal to a0 by 2 plus sigma n equal to 1 to infinity a n cos nx plus sigma n equal to 1 to infinity b n sin nx, where a0 is 1 by pi integral minus pi to pi f of x dx, an equal to 1 by pi integral minus pi to pi f of x cos nx dx, and then bn equal to 1 by pi integral minus pi to pi f of x sin nx dx. Suppose this case will be even, therefore function is even, integral minus pi comma pi. the Fourier series formula is f of x equal to a0 by 2 plus summation equal to 1 to infinity a n cos nx. Here the Fourier coefficient a0 equal to 1 by pi, 2 by pi integral 0 to pi f of x dx, a n equal to 2 by pi integral 0 to pi f of x cos nx dx. So here the Fourier coefficient bn will become 0 because the function is even. You know already that what is even function? The function f of x is even if f of minus x equal to f of x. Give the example means, so f of x equal to x square cos x modulus x, these functions are all even functions. In a similar case, we can next speaking about the odd function. So f of x is odd function in the interval minus pi comma pi. The Fourier series will become, so f of x equal to sigma n equal to 1 to infinity bn sin nx. Okay, so where bn equal to 2 by pi integral 0 to pi f of x sin nx dx. So what is meant by odd function? F of minus x, the function f of x is odd function, f of minus x equal to minus f of x. Therefore, example for odd function f of x equal to x cube, sin x, these are all odd functions. Neither even nor odd means you will take one even function and then one odd function. You can combining these two, which is will be neither even nor odd. So give the only example, f of x equal to x plus x square, f of x equal to sin x plus cos x. These are all functions which are neither even nor odd. So we can discuss about the two formats of the Fourier series in the interval 0 to 2 pi and then minus pi comma pi. We can complete this form. Thank you.